Hello ladies and gents, welcome to another episode of Solder with the Coder. Today I want to walk you through how to restore the traces on a HDMI circuit. So this is going to be a generalised tutorial, but the console that I'm focusing on for the particular tutorial is going to be an Xbox One S, and that is because this is the most common console that I see to have trace repair on. So what I'm going to be doing is I'm going to be showing you how we can restore the traces on the circuit so as the HDMI circuit can work again. And this is a donor board, and I've deliberately damaged this board. So what I did was I added some leaded solder to the ground legs. I added a little bit of leaded solder here, a little bit of leaded solder here, and then basically just left these ones with lead free. And if you don't know, lead-free solder has a much higher melting temperature than leaded solder does. And what that did was it caused certain pins to melt before the other ones. And that's obviously a deliberate attempt at sabotage, but it's one of the most common things that I see where people will try and lift up the HDMI port too early. Some pins will be melted, some pins won't, because the hot air isn't perfectly even, and that will in turn pull up the traces. So as you can see here, we've got 1, 2, 3, 4, 5, 6, 7, 8 damaged traces out of the 19 on this particular circuit. And what we need to do is we need to run some jumper wires to the corresponding points on the motherboard. So for example, pin number 19, we can follow that down and that goes to here. So it goes to this via here, and it also goes to this resistor here, and we can use either of these, and I'm going to try and use as many examples as I possibly can in this video. But this, like I said, is mainly down to user error or sloppiness on the technician's part. Sometimes they might be rushing and they want to just get the job done so they can go home, or they might have so much work on that they're just not paying attention and they end up doing these kind of things. So it's going to be something that we all run into at one point in our lives, whether we've been sent the console by someone else to fix or whether we have damaged the port ourselves. So the first thing we need to do to be able to restore this circuit is we need to clean up and evaluate what kind of damage we're looking at. So we have obviously several traces here which we can just pull away because these traces can no longer be used, and we want to make sure that we at least try and save a little bit of the circuit. So for example, this one here on pin number 18, when we've got a case where we've got a little bit of the trace left, we want to try and save that bit of trace. We want somewhere to solder to on the top of the board rather than having to run jumper wires around the edges of the board, if possible. So what we do in this scenario is we would basically trim it away as far away as we can, leaving as much of the trace as possible. So we just cut it away with the blade. If we do get a situation where we don't have anywhere to solder to on this side of the board, then what we would have to do then is figure out where that trace went to and then solder it to the end point. So I'm not 100% sure where this goes before it gets to its end point. I don't have the pinout diagrams for the Xbox One HDMI circuit, unfortunately, but luckily for us, that trace we can still use. The next thing we want to look out for is going to be traces that we can still use that are damaged. So for example, this trace here is just a ground, but we can still use this, and even if we couldn't, it's not necessarily a bad thing because there's several other ground points on this HDMI circuit, and one ground point missing is not going to be the end of the world. So we could still potentially use that by just basically pressing down on it and pushing it back down to the board. We would struggle to solder it, but I'm going to try and leave it there just as a good scenario to use for the tutorial. So once we've evaluated how many pins we've got missing, so we've got another one here for pin number 19. Once we've cleaned them up, we can basically clean up the rest of the port. So we want to make this as clean as we possibly can, so it's as easy as possible to get the new HDMI port on and run the jumper wires. So what we want to do first is we want to wick away the old solder, and by wicking away the old solder we're also going to be able to see the true extent of the damage. So if we get this in full view here, what we're going to do is we're going to take the soldering iron and we're going to replace the solder that's on there with fresh leaded solder. You may have already done this before you try to remove the port, or someone else may have done this, but we're going to do it again just to make sure. So we're going to replace that solder with leaded solder just to lower the melting temperature. We don't want to cause any more damage than necessary, so when we're cutting away traces, we don't just want to think, oh, that one's a tiny bit loose, so let's just remove it. If we can solder to that point, then that's ultimately what's going to be the best option, because that's going to be an easier repair for us, and it's going to be an easier repair if it ever happens again in the future where the HDMI port gets broken, for example. So what we'll do is we'll wick away the solder using some solder braid, and we're going to go with the direction of the traces. So from top to bottom, we're going to go with the direction of the traces. We're not going to go from side to side, because these traces have already been weakened, and going side to side could cause further damage. Like I said, we don't want to be causing more damage than is absolutely necessary. So with that done, what we want to do is we want to clean up, and then we can get the full picture of what's happened. So I'm going to use some isopropyl alcohol, and I'm just going to brush from top to bottom, same as we did with the wick. Just brush from top to bottom and get rid of all of the old flux, get rid of any residue, get rid of the broken traces. And then I'm going to use some hot air to dry the isopropyl alcohol up. And while the hot air gun is still turned on, I'm going to flip the board around, and I'm going to focus my attention on these ground legs. So I want to clean these ground legs out if I can. So I'm going to heat up the area until I see the solder molten. We're getting fairly close. And then I'm going to come in with a solder sucker and just suck up any excess solder. Just like that. I'm going to suck up the solder and do this side as well. And now we've got a nice clean area to work with. The ground legs are nice and clean, and we can just drop a new port into this. So flipping the board back around, you can see that we can just drop a port inside here. So I'm going to be using the port that was actually on the HDMI input side. And I'm just going to drop this port in place. And then I'm going to angle the board and just make sure that the port is in line, make sure that it's nice and even, and that the pins are as flat to the board as possible. And then what I'm going to do is I'm going to add some flux, and I'm going to try and solder just a couple of these legs. So I'll pre-apply some solder onto the tip of the iron. Press down on the port. And then I'm just going to add a little blob of solder. So I'm not worried about any kind of bridges at the moment. I just want to hold that port in position so as we don't end up causing the port to fall out when we flip the board around, which is what we're going to do now. And what we're going to do now is we're going to solder the ground legs so as we can secure the port in place, and then that means we're going to be able to work on it from the other side without knocking it all over the place. So I'm going to add some more flux. And then I'm just going to apply some solder to the ground legs like we normally would. I'm going to wait for a few seconds just for the heat to transfer. Don't forget these are very big ground planes, and it's going to take a lot of heat. Now I'm going to push down on the port from the other side. So my finger's just here, and then let go. And that should be in position now. And then this one here It's not the same on all ports, but that one there, the ground leg is always smaller. Let's just make sure that we've got some nice even joints. And there we go. Nice shiny solder joints, which is exactly what we want to see. So we're done for this side. So what we can do now is just clean that up using some more isopropyl alcohol. In this case I find it easy to just use a toothbrush just to give it a good scrub. And then just dry the area off using hot air again. So the reason we dry the isopropyl alcohol off is so we can inspect the joints, make sure that they're nice and clean, make sure they're nice and shiny. And as you can see from that, those joints are beautiful. Absolutely beautiful. So let's flip the board back around now. And next we want to tackle this big blob of solder. So all I'm going to do is I'm going to wick this solder back off the board now. And yes, it's a little bit of a waste of solder, but at the same time that helped us to get the port in position and not have to worry about it not being aligned properly or not being flat to the board. So it's a little bit of a waste of solder, but it does help. So I'm just going to come in with the solder braid and I'm going to wick away these blobs of solder. There we go. Alright. And as you can see, there's still some very big blobs there. The reason for that is because my soldering iron just decided to turn off, which it keeps doing today for some reason. So let's just spread this solder across. Let's bring it all into one nice bunch. Then I just want to wick away this big blob of solder that's in the middle of the port. So I'll come back in with the solder braid. And just clean up. There we go. That's beautiful. And then I can just resolder these joints. Run the iron across. For the purposes of this tutorial, it doesn't have to be perfect, but obviously if you're doing this as a live case, you want to have this port perfect. You don't want to have to go back and do something else to it afterwards. So with that out of the way, what I'm going to do is I'm going to clean up using isopropyl alcohol, and I'm going to use a cotton swab now because we need to get inside the port to make sure it's nice and clean. So a bit of isopropyl alcohol on a cotton swab. Just give it a nice scrub, make sure it's nice and clean and that we can see underneath the port where the pins are. So let's just zoom in. And as you can see, these pins are soldered. So because I used the drag soldering method, these pins here will be nice and solid. So this one will be loose because there's no trace there. This one here is the one that was damaged but still usable, so you can see that trace is moving with the pin. That one's missing, missing. That one's there. Solid, solid, solid. And the rest of them are solid, and then them two are missing. So the main part of the port is done, or at least the ones that are there. So the pins out of there are all done, but what we need to do now is we need to run jumper wires to the ones that are not there, so the ones that are missing. So like I said, I want to give as many scenarios as I possibly can in this video, and obviously these traces removed themselves wherever they removed themselves. I couldn't really help where they got pulled up. So this is basically a situation where could happen because I didn't stage which traces was removed. I just let whichever ones wanted to come up, I let them come up. So what we need to do now, like I said, is we need to run some jumper wires to the traces themselves, or to the end point of the traces. So we're going to figure out where they go. So pin number 1 goes to the EMI filter, so that's going to be this EMI filter here. And as you can see, that EMI filter, the traces come all the way up. Now, because this is an Xbox, and I personally know from experience that these are passive filters, the trace is complete from here all the way down to the HDMI encoder, and then the filter's just there just to filter out noise, but the trace is complete even without that filter there. So what I need to do with those in this case is I need to remove the filter completely, and the reason for that is because I need to see just how much of the circuit is damaged. So I'll remove these filters for the purposes of the video. I do want to treat this like a live case. And then I'm just going to clean up the area a little bit. We can see here that they've basically come up until the middle of the actual trace itself. But as you can see here, these traces here, the circuit is complete. We can actually see the trace and see that it's got a continuous path. So just in the middle here, we can see that there's a continuous path. So what we're going to need to do with these ones is we're going to need to run this trace to this part here. So basically, these filters are essentially a QFN chip. So if you haven't watched the QFN trace restoration video, I highly suggest you do that now. And then come back to this one. So we're going to have to use several methods in this particular repair. So what we want to do is we want to run a jumper from the pin itself, so this pin here, all the way down to the end point, which is where the filter sits. So the jumper wire that I use for these particular repairs is actually the insides of a motor, and the motor comes out of a microwave. So it's a little side fan that you find in the microwave, and it basically cools the microwave, but it makes perfect jumper wire for this kind of repair. So that's the jumper wire that I'll use for most repairs, depending on the situation. But for this one, I don't know the exact diameters. I think it might be around about 2mm. But for this particular repair, that's the jumper wire that I'll use. So like I said, what we need to do is we need to run a jumper wire. So very steadily, we're going to get this one in position. And this one I've already got the end tinned, but I will be showing you how to tin the end on some of them. And what I'm going to do is I'm just going to come in with the soldering iron. And just basically tap it to solder it into place. We don't need to follow all of these zigzags. They are there for timing, but it doesn't affect it if we don't follow them. It's not going to affect the HDMI signal. But once I've tapped that in place, what I want to do is I want to be able to solder it properly, because that right now is not secure. And the only way to solder it properly is to hold it in position. And that did come off the pin there. And the end pins might be a little bit difficult because of clearances. I am going to get a smaller tip because that one's a little bit too large. So we can run that jumper wire to there, and as you can see, that's nice and secure now. And then, like I said, we're going to need to come down to the end point. So we follow it down until we can see where the trace is meant to run to. So we're going to trim the wire at the end. And then we've got enough for that one particular trace. So without worrying about the end point for now, what we're going to do is we're going to run the next jumper And the next jumper that we're going to run is going to be this pin just here. But we do need to tin the trace. So what I'm going to do is I'm going to add a little bit of flux. And flux is going to help anyway, because we need to be able to get nice even joints on these. So what I'll do, now I've added the flux, I'm actually going to melt that flux, and then I'm going to hold this jumper here in place. And just make sure it's got a nice smooth connection. Make sure it's got no dry joints. Just like that. And then, like I said, we're going to come on to the next jumper wire now. So we're going to want to tin this jumper wire before we can work with it. So what I'll do is I'll just basically take the edge of it and just run the soldering iron across the wire. There we go. And then we're just going to solder this new jumper to the pin that we need to. And this is going to be essentially what we need to do to restore these connections. So I won't complete all of these in here. I'll do a couple, but I'm not going to complete all of them for the sake of the video length. And that one is good to go. So we'll trim the next one. So again, we're going to line that up. There we go. And I'm going to skip the other EMI filter because, like I said, we want to keep this video not short, but we want to keep it as short as we can while still conveying as much information as we can. But if we do all of those traces, then it's just going to get repetitive. So we're going to leave those hanging there for a while, and we're going to do the other traces on the end of the pin, on the end of the port where we've got the wires. And what we need to do with these is we need to expose some of the copper that's underneath the conformal coating or the solder mask, and basically give us a pad to solder to from the pin. So just scrape away with the blade, and for this one we're actually going to solder to the resistor so we can show another scenario as well. So we scrape away with the blade, and then what I'm going to do is just clean up the little bits of debris that I've scraped away off the board, in this case the conformal coating. Let's give it a wipe down with a bit of isopropyl alcohol there. And then just dry it off. Before we actually run this jumper, we need to prep this newly formed pad. So what we're going to do is we're going to add some more flux here to this area here where we're working. That's a little bit too much, but it's fine. And then all I'm going to do is just come in with the soldering iron. And just tin that trace. It's a little bit difficult with this tip, you might want to swap tips for this. And I think that's exactly what I'm going to do. So I'm going to swap to a bigger tip that's got a bit more thermal transfer on it, or thermal mass. And just basically prep that pad so it's ready to accept a jumper wire. The one thing I did do when I was messing around with that trace was I accidentally bridged a couple of pins on the end. So let's just fix that now. There you go, just scrape that away there. So like I said, we don't want to have any bridged pads here. I'm going to zoom out a little bit just so we've got a little bit more light. And then once again we need to start a new trace. So we'll just tin the end. And I actually do need to zoom in just so I can see. But the flux that was there has burnt away because of the heat. So I'm going to clean that flux up and I'll add some fresh. To allow me to see better and actually see what I'm doing. There we go. So I'll just add a little bit more there. Just tin that jumper wire. And then just solder it to the pin. So I'm going to make sure that this is secure by holding the jumper wire with tweezers. And then for this one, because it's such a short run, I'm going to solder this one right away. So I'm just going to use the heat of the iron to tin the jumper. And that's almost there. There we go. And then I'm just going to wiggle it until it breaks. There we go. Perfect. So let's clean that up again. One of the problems with running jumper wires is there is a lot of cleaning involved. And the reason for that is because, like I said, the heat of the iron and constantly using the iron in the same area for several minutes sometimes does tend to melt and burn the flux. So it's best to just clean up every so often, just so we can see what we're doing at all times. Certainly don't want to be doing this kind of work blind. That will do. So that's good enough. We can see what we're doing now. And as you can see, that jumper wire is in position. And basically, that one is done. So for the last example, I'm going to be using the resistor. So the end point I'm going to be going to for this one is going to be the resistor. and that is just here. So I could use this via, but I've already done that for this one, so I want to show you an example of doing it to the resistor itself. Once again, I'm just going to come in with the soldering iron and the jumper wire. And just solder the jumper wire to the pin. So let's make sure that that's secure. There we go. And then for this one, because we need to basically position it as well, what I'm going to do is I'm just going to use the tweezers and just basically shape this jumper wire so as it's not in the way of anything else, and also so as it looks nice and tidy as well. So like I said, we could go to that via there, but I'm going to go to the resistor instead. So I'm going to work out exactly how much I need to make a neat and tidy jumper. So I'll work out what I need. And trim it off. So you can see there that that's going to be nice and tidy. And then, like I said, we want to just solder that to the actual location itself. So I'm going to pull this away so as I don't knock any more components off. And I have just broke that jumper wire off the pin, so that's fine. I just want to get this end tinned. So all of the bending has caused it to break away, but that's absolutely fine. Let's just tin this end of the jumper wire. There we go. And then I'm going to bring the jumper wire back into position. And I did go a little bit out of focus there. I am sorry about that. And then we're going to run that to the end point. And then we're going to solder it to the resistor. And you can see there we've got a nice blob of solder there, so that's going to be a nice strong connection. And what I want to do is just push this so as it's flat to the board. There we go. Keep that nice and flat on the board there. And then we can focus on these ones. So we need to actually solder these ones now. And this first pin that we run, we're just going to bend this back into shape. We're going to use the tweezers and the blade to assist. Could use a couple of pairs of tweezers as well. We just want to get that roughly in position there. It does not have to be perfect. We're going to hold it down and then tin the jumper wire. And once again, just solder it to the end point. The same with this one. And this one is actually a tiny bit short, which is perfect because I can show you how to deal with it. So because this one's a tiny bit short, I need to either run the jumper again or just extend this jumper wire. And I'm going to choose the latter. So all I'm going to do is just heat up the area and pull the jumper wire down a little bit. I'm just going to move the jumper wire so as there's less on the actual pin and more hanging free, and hopefully it gives me enough to work with. And I think it has. I think it's given me enough. Yep, there we go. Perfect. There we go. Okay. So now what I want to do is I basically want to clean this area up and then secure the jumper wires in place before I use any hot air to solder the EMI filters back on. So I'm just going to clean up here. And you can see one of those EMI filters have ended up back on the board there. I'm not sure how that happened, but never mind. Let's just clean up underneath the port as well by the pins. So to do that I'll use a cotton swab again and just basically give it a nice clean there. And I seem to have lost that jumper again, but that's fine. I will fix that in a second. So zoom in. I'm going to reposition the jumper wire so as it's in a little bit of a better place. In terms of the bends and curves. And that's nice and secure now. So a little bit of persistence and perseverance and that is nice and secure. So what I want to do now is I want to secure these jumper wires in place so as I can actually use the hot air around the area either now or in the future. And the way I'm going to do that is by using some solder mask. I'm basically gluing these jumper wires in place. So I'll just add a coating of solder mask over it. So as you can see I've got a nice layer of solder mask there. And I'm going to do that to all of the traces that we've restored. So we don't want to do that all over the board, but we do want to do it to the traces that we're restoring. This one on the end here, we're going to cover up the entire area. And then this one here we're going to cover up the resistor as well, or at least the one end of the resistor, just to stop the hot air from affecting it. And then what we need to do is we need to cure this solder mask. So the solder mask is cured by UV light, or the 405 nanometer wavelength light. So I'm going to be using a 405 nanometer wavelength laser, and if you are epileptic, then please look away now. I don't want to be responsible for any kind of epileptic seizures. So if you do suffer epilepsy, I'll tell you when it's safe to look. This is going to take a couple of minutes, but I will fast forward through it. So I'm going to use the UV pen, or the 405 nanometer pen, in 3, 2, 1. Basically what I'm going to do here is I'm going to just hold the pen over the UV mask for about 20 seconds to 25 seconds, just moving backwards and forwards, up and down, and curing each one of these traces. So what we want to see here is we want to see the UV mask go hard, and then it will basically act like a glue. And that UV mask should be cured. It should be safe to look now for people who suffer with epilepsy, and we should be good to go with this. It should be nice and secure, and it shouldn't go anywhere now. So if we just give these a little tap test or nudge test, you'll see that the end will move but the rest of it won't. And you do want to make sure that you do have a clean surface here. This hasn't fully hardened, so I do need to do it a little bit more. So I'm going to use it again. Okay, I'll give that another test. And yep, that has hardened. We do still have a little bit which hasn't hardened there, but that's not going to really hurt it. But as you can see now, those traces are nice and secure. And same with those ones, it's not fully set and the board wasn't completely clean, but it is basically in position. So what we need to do now is we just need to finalise the trace restoration by replacing that EMI filter. I'm not going to replace the both, but I will replace the one. So what I'm going to do is, finally, I'm going to add a bit more flux here. I'm going to pre-tin these pads again, including the jumpers that we've just run. There we go. And then all I'm going to do is just solder the EMI filter like I normally would. So just using hot air. Let's add a little bit more flux here. And there we go. So let's just clean that up now once more, and then I'm going to do some tests and make sure that these are all connected, and then in a live case this would be pretty much ready to go. So I'm just going to get rid of the flux that's here and the bits of grime, and as you can see, those jumper wires stayed put even with using hot air around leaded solder, which is going to melt fairly easily. And that's it. So what I'll do now is I'll use the multimeter just to confirm that we've actually got a connection from the start to the end points, and just double check, make sure that it's all right and that it would be ready to go if it was a live scenario. So what I'll do is I'll use the multimeter in continuity mode. So continuity mode is a mode that beeps when we complete the circuit. So if we go from one point to another, we should get a beep. So pin number 1, if we go from the pin itself to the bottom of the EMI filter, you can hear a beep, which means we've got a completed connection. And then pin number 5, we have a completed connection as well. Pin number 18 we can't actually check because I've covered up the via, so I'm not going to be able to check that one, but I can check pin number 19. And as you can see there, that does go to the resistor, which means that we've got a completed connection. So in the live scenario, that would be ready to go. And that is how we restore the traces on a HDMI circuit. So that's going to be it for this video. If you have any comments or questions, leave them down in the comment section down below and I'll do my best to answer them. If you have any suggestions for things that you would like to see me do and things you would like to see me teach, be sure to let me know and I'll do my best to get a video made on that subject. If you want to see more repair videos, then be sure to hit the subscribe button and turn on the bell notifications so that you're notified every time that I upload. And finally, if you want to support the channel and you enjoy what I do, then you can hit the join button down below and become a channel member for as little as £1.99 per month. And that's going to be it for now, but thank you very much for watching, and until next time, see you later. Bye for now.